Welcome to this quick tutorial on how to work your way through this worksheet. I believe the information in VCAST 1.3 should be sufficient for you to answer number 1. Slightly different example, ducks and shots being fired, but the concept is identical, being able to determine the difference between precision and accuracy. Let's go down here to number 2. Okay. The way to do number 2 is I'm going to do the first one for you. So number 2, you have these 5 different values, right? There are 5 different measurements. And what you do is you find their average, okay? Now, their average in this case happens to be 15.35. In the VCAST, we talked to you about how to find the uncertainty by looking at a variety of measurements rather than assigning the uncertainty ahead of time like we did based on our measuring device. So you could just go ahead and make the measurements. And in the VCAST, I gave you 2 different ways. I gave you the standard deviation way, which is more advanced than we need. So I'm going to show you the simpler way. You determine the average, and then for each value, you determine how far away it is from the average. Right, so 0.03 for that one, 0.02, 0.02, 0.03, and 0.00. And then you just look at which one was the furthest from the average, and that's the one you go with, right? So we had 2 0.03s. And so just to be on the conservative side, we'll say that the uncertainty of those measurements was 0.03. That's a very simple way to determine the uncertainty of a bunch of different measurements that vary due to random error. So you can do set B here on your own. Let's move down the page a little bit here. Okay. So down here we have in number 4, we have beaker situation. And again, what you're going to do here is you're going to find the uncertainty, okay, and the average. So the average of these 2 numbers, right, if I take their average, is 208.8. And then I determine, well, how far does each one of the values vary from the average? Well, this is 1.6 more, right? This is 1.6 less. So my uncertainty is 1.6. Now we like to typically keep our uncertainties to 1 sig fig, so I could rewrite this as 209 plus or minus 3, right? 3.2 is 3. So that would be your final answer. You'll do the same for this row here, right? And then for the final one, you just add the uncertainties of these 2. So you'll have 3 here and 3 here, so you'll have a this shouldn't be 3, this should be 2, sorry, 1.6 rounds to 2. So the final uncertainty will be 4 here because you have uncertainty of 2 from this one and this one. Okay, let's look at the back page and see if there are any issues here. All right. On the back page, number 5 is very similar to number 4. You should be able to do that on your own. And then you get a chance here to make some more measurements. And again, you're going to practice your skills from the first few days in the measurement stations. So for each of these different scales here, start with the least count and then determine whether or not you can justify going less than the least count, right? Like half of the least count, or maybe you should just stick to the least count. And finally, you actually have a better version of the triple beam balance here than you do on your black and white worksheet. But I think the rest of these you should be able to answer pretty well.